What I wish I knew back in high school biology class is just how fascinating and intricate our body's mechanisms are. One of the most amazing processes is how our body stops bleeding, a process known as hemostasis. Hemostasis is the body's way of preventing excessive blood loss when we get injured. Imagine you get a small paper cut. It might seem minor, but without hemostasis, even such a small injury could become a major problem. So, how does your body stop a paper cut from becoming a major disaster? The answer lies in a well-coordinated series of events that your body initiates almost instantly. Spoiler, it's called hemostasis. Hemostasis literally means blood stopping, and it's a 5-step process that kicks in when you get injured. The first step is called vascular spasm. This is where your blood vessels constrict to reduce blood flow to the injured area. Think of it as your body's emergency brake. When you get injured, your blood vessels get the memo to constrict, reducing the amount of blood that can flow through them. This is crucial because it minimizes blood loss right from the start. Step 1. Vascular spasm. Your blood vessel gets the memo to constrict, reducing blood flow. Think of it as your body's emergency brake. This immediate response is vital because it buys your body time to activate the next steps in the hemostasis process. Step 2 is platelet plug formation. Platelets are tiny cell fragments in your blood that rush to the site of injury. They stick to the exposed collagen in the wound, forming a temporary plug. Think of platelets as the first responders in an emergency. They arrive quickly and start working to patch up the damage. Step 2. Platelet plug formation. Platelets, or tiny cell fragments, rush to the scene and stick to the exposed collagen in the wound, forming a temporary plug. These platelets release chemicals that attract even more platelets to the site, creating a sort of platelet party at the wound. This temporary plug is essential, but it's not enough to stop the bleeding completely. That's where the next step comes in. Step 3 is the coagulation cascade. This is a complex chain reaction where proteins in your blood activate each other in a specific sequence, ultimately leading to the formation of fibrin strands. Step 3. The coagulation cascade. This is a chain reaction of proteins activating each other, culminating in the formation of fibrin strands. Fibrin strands are like tiny threads that weave through the platelet plug, turning it into a more stable clot. This makes the plug much stronger and more effective at stopping the bleeding. These strands weave through the platelet plug, turning it into a more stable clot. The fourth step is clot retraction. This is where the clot tightens up, pulling the edges of the wound closer together. This not only helps to stop the bleeding, but also makes it easier for your body to heal the wound. Next up, step 4, clot retraction. The clot tightens up, pulling the edges of the wound closer together, making it easier for your body to heal. This step is like cinching a drawstring bag. It brings the wound edges together, reducing the gap that needs to be healed. Finally, we have step 5, fibrinolysis. Once the blood vessel is repaired and the wound is healing, your body no longer needs the clot. Plasmin, an enzyme, breaks down the fibrin mesh, dissolving the clot. Finally, step 5, fibrinolysis. Once the vessel is repaired, plasmin breaks down the fibrin mesh, dissolving the clot. This is like taking down the scaffolding after a building is complete. The clot has done its job, and now it's time for it to go. So next time you see a cut healing, you'll know it's hemostasis in action. This entire process is a testament to the incredible complexity and efficiency of the human body. It's amazing how all these steps work together seamlessly to protect us from what could otherwise be a life-threatening situation. So next time you see a cut healing, you'll know it's hemostasis in action. Like and subscribe for more cool biology insights. Like and subscribe for more cool biology insights. Like and subscribe for more cool biology insights.